Okay, so in this class we are going to discuss about different types and formats of MapReduce. Actually, in MapReduce programming, there are two major phases. One is map and next one is reduce. And in between this map and reduce, there is a phase called intermediate output. So now whatever it may be, either it may be mapper or reducer, always the key value pairs are input and key value pairs are the outputs for mapper as well as the reducer and key value pairs. So now here, if you want to work out on this particular MapReduce programming, key and value is the major will play the major role. So in this section or in this chapter, we are going to discuss how these key value pairs are managed. Okay, so here map and reduce are the two functions. Then map will always take k1 as key and v1 as values. Okay, so by taking key and value as input, and it will process it, the mapper will process those key and value, and it will generate the list of k2 and k2 and v2. These are the keys. The k2 v2 are the output key value pairs of the MapReduce. So k1 v1 are the input key value pairs, and k2 v2 are the output key value pairs for the mapper. Okay, so this is the map function. These are about map. Next, reduce function. The reduce function will take k1 list of k1 and k2 key value pairs that are uh, given by maps. Like these maps, number of mappers will be there, and all the maps returned key value pairs will be sorted and shuffled, and they will make this list of key k2 and value v2 into this format, k2 and list of values, and those k2 and list of values will become the input to the reducer. Then reducer will try to aggregate those k2 and list of values v2, and they will they will generate a list of k3 and v3. So k2 v2 and k3 and v3. So k3 and v3 are the final output values. K3 v3 are the final output values. Okay, so this is how the maps and reduces will work. So number of maps depends on the number of blocks. Here I'm taking this is one block, and like this number of blocks will be there in different data nodes. Every block is having its own map, and from each block the map will take the data will take the data in the form of key and value pairs, and those key value pairs will be processed by mapper, and that mapper will generate the k2 and v2. Okay, so like this. So if you observe here, the total MapReduce programming paradigm will handle the key and value pairs. So that is the major importance of key and value pairs, and why these key and value the data is converted into key and value pairs. That is a major issue here. So the main reason is here, if you want to transfer the data across the network, here we are not working in a single system, we are working in the distributed system. If you want to distribute the data in a distributed network, a cluster or a distributed network, then we need to make these data somewhat flexible and secured. Somewhat flexible and secured. So that's the reason why these the data, whatever the data that was there in the raw block of data is converted into key value pairs, process it, and again it will convert it into a list of key value pairs, and again the list of key value pairs will convert it into keys and values, key and values, list of values, and those key list of values will be converted into finally again key value pairs and K3. This is a final key value pairs. So the mapper syntax. So if you want to implement the mapper syntax, we already discussed how to implement the mapper class. So but in terms of key value pairs, if you want to discuss the main skeleton of mapper function is public class mapper. This is one set, that means input key value pairs, and here this is output key value pairs. Okay, so this is the key and value as input to the mapper, and this is the key and value to the output of the mapper. Then the mapper is a superclass. Mapper is a superclass. If you want to implement your own mapper, you have to extend this class to that particular mapper. So in that, a mapper context will be there. So context. So in that you have to use these values. So this will like a constructor for um, your class mapper, and it will returns a context in which context your map is running. Then here there is a method in mapper. Here there is a method in mapper that is called map, and key, this is the key that was transferred, and value that was transferred here. We already discussed this is the input key and input value. These two values will be mentioned here. Then this context, whatever the context that was there, that will be returned here, and it will throw IO exception and interrupt exception. And finally, once these key and values are entered into the mapper, then those key values will be processed here. With some logic, it will be processed here. Once they are processed, and finally it will generates list of key and values. So those list of key values will be given by the mapper as output like this, context.write, and this is the output key and this is the output value. Like this, number of key value pairs will be generated, and those will come under is K2 and V2. Okay, so mapper will take K1 and V1, and it will returns K2 and V2. It returns the K2 and V2. In between these two, the process, so K1 and V1 will be taken and they will be processed and they will convert it into K2 and V2 under this particular map function, which is the method that is there in the mapper class. So this is all about a mapper class syntax. Next, reduce class syntax. Here the reducers input is the key that was given by different mappers, and values, its corresponding values given by different mappers will become the input key value pairs. So that is K2 and V2. That's the reason why K2 and V2 are the mappers output, and here those key and value pairs that are given by the mapper will become the input to the reducer. Then finally it will generate K3 and V3. So output key, output value, and this is the reducer class. In that context is reduce context. So 1 minute. Someone Okay, so here reduce class, in that K3 and V3 or the input, K2 and V2 are the input and K3 V3 are the output. Then in that reduce context reducer context will be there. It will generate the, it will returns the context. Then in that reduce is a method. In reducer class, reduce is a method, and input class and list of input values, and those will be processed here. And here also context dot write. So I have forgotten here. Context dot write and key and value. The key and value, that is key K3 and value V3 will be returned by the reducer. Okay, so this is how the mapper and reducer will work in MapReduce environment. So, but here only map, not only the MapReduce, in between the map and reduce, sometimes you have to go for either combine or partitioner. The functionality of combiner is already we discussed. Reducer will finally aggregate, but if you want to aggregate a mapper level aggregation, then we'll go for the combiner. Okay, reducer is the ultimate. At the end of the map reduce, the reducer will aggregate the key value pairs. But if you want to aggregate in the mapper level itself, the reducer will be implemented at the end of every individual map. At the end of every individual map, reducer will be applied, and that particular reducer that was implemented individual map will call it as combiner. Okay, so that's the reason why if you observe here, K1 is input and key and value, and K2 is output, key and output value of the mapper, and these will take it as the combiner will take it as input, and it will generate the K2 and list of V2, and it will generate the K2 and V2, list of K2 and V2. Okay, so here list of K2 V2 will become the reducer's input. List of combiner's output will become the reducer's input, and then the list will become final list of K3 V3 will become the output. So this is another type of MapReduce handling. Okay, so mapper, okay, mapper, reducer. This is the primary thing. Then what is the next format? If this is the mapper, and immediately this particular one reducer, then intermediate output, then reducer. If this is the case, then we can call it as, this is combiner. This will call it as combiner. Instead of reducer, I'll call it as combiner. And mapper, every mapper is having its own combiner, and it will generate the intermediate output. Like this, that output will be supplied to the reducer, and ultimate output will be stored. So that is all about combiner function. Here also key value pairs, every the input mappers input is key value pair and output is key value pairs. Combiners are also key value pairs and key value pairs. Reducers key value pairs. So every module of the MapReduce programming will handle the key value pairs. Then another very important thing here is partitioner. Okay, so if number of mappers are there, and every mapper is having its own intermediate output, and it was sorted and shuffled, and one reducer is there, for example. So the total intermediate output of different mappers, okay, number of input intermediate outputs that are generated by the mappers. So here the mapper 1, mapper 2, mapper 3, all are supplied to a single reducer. If you have the single reducer, and it will generate the output. But in some situations, you may have more than one reducer. You may have more than one reducer. If you need more than one reducer, if how many number of reducers that you installed, those many output files will be generated. Okay, so now how to supply this input to these reducers? Here, this is one of the intermediate output that was given by the mapper 1. This is a intermediate output that was given by the mapper 2 and mapper 3, like this. So if you want to supply key value pairs to different reducers, reducer 1, reducer 2 and reducer 3, a default partitioner will be there. This default partitioner will divide the total intermediate output into 3 parts. The first part is